Climate change mitigation consists of actions to limit the magnitude or rate of long-term climate change. Climate change mitigation generally involves reductions in human emissions of greenhouse gases. Mitigation may also be achieved by increasing the capacity of carbon sinks, e.g., through reforestation. Mitigation policies can substantially reduce the risks associated with human-induced global warming. Mitigation is a public good. Climate change is a case of the tragedy of the commons. Effective climate change mitigation will not be achieved if each agent acts independently in its own selfish interest, suggesting the need for collective action. Some adaptation actions, on the other hand, have characteristics of a private good, as benefits of actions may accrue more directly to the individuals, regions, or countries that undertake them, at least in the short term. Nevertheless, financing such adaptive activities remains an issue, particularly for poor individuals and countries. Examples of mitigation include switching to low-carbon energy sources, such as renewable and nuclear energy, and expanding forests and other sinks to remove greater amounts of carbon dioxide from the atmosphere. Energy efficiency may also play a role, for example, through improving the insulation of buildings. Another approach to climate change mitigation is climate engineering. Most countries are parties to the United Nations Framework Convention on Climate Change. The ultimate objective of the UNFCCC is to stabilize atmospheric concentrations of GHGs at a level that would prevent dangerous human interference of the climate system. Scientific analysis can provide information on the impacts of climate change, but deciding which impacts are dangerous requires value judgments. In 2010, parties to the UNFCCC agreed that future global warming should be limited to below 2.0 degrees Celsius relative to the pre-industrial level. With the Paris Agreement of 2015, this was confirmed, but was revised with a new target laying down parties will do their best to achieve warming below 1.5 degrees Celsius. The current trajectory of global greenhouse gas emissions does not appear to be consistent with limiting global warming to below 1.5 or 2 degrees Celsius. Other mitigation policies have been proposed, some of which are more stringent or modest than the 2 degrees Celsius limit. Background: greenhouse gas concentrations and stabilization. One of the issues often discussed in relation to climate change mitigation is the stabilization of greenhouse gas concentrations in the atmosphere. The United Nations Framework Convention on Climate Change has the ultimate objective of preventing dangerous anthropogenic interference of the climate system, as is stated in Article 2 of the Convention. This requires that greenhouse gas concentrations are stabilized in the atmosphere at a level where ecosystems can adapt naturally to climate change. Food production is not threatened, and economic development can proceed in a sustainable fashion. There are a number of anthropogenic greenhouse gases. These include carbon dioxide, methane, CH4, nitrous oxide, N2O, and a group of gases referred to as halocarbons. The emissions reductions necessary to stabilize the atmospheric concentrations of these gases varies. CO2 is the most important of the anthropogenic greenhouse gases. There is a difference between stabilizing CO2 emissions and stabilizing atmospheric concentrations of CO2. Stabilizing emissions of CO2 at current levels would not lead to a stabilization in the atmospheric concentration of CO2. In fact, stabilizing emissions at current levels would result in the atmospheric concentration of CO2 continuing to rise over the 21st century and beyond. The reason for this is that human activities are adding CO2 to the atmosphere far faster than natural processes can remove it. This is analogous to a flow of water into a bathtub. So long as the tap runs water into the tub faster than water escapes through the plug hole, then the level of water in the tub will continue to rise. According to some studies, stabilizing atmospheric CO2 concentrations would require anthropogenic CO2 emissions to be reduced by 80% relative to the peak emissions level. An 80% reduction in emissions would stabilize CO2 concentrations for around a century, but even greater reductions would be required beyond this. Other research has found that, after leaving room for emissions for food production for 9 billion people and to keep the global temperature rise below 2 degrees Celsius, emissions from energy production and transport will have to peak almost immediately in the developed world and decline at California 10% per annum until zero emissions are reached around 2030. In developing countries, energy and transport emissions would have to peak by 2025 and then decline similarly. Stabilizing the atmospheric concentration of the other greenhouse gases humans emit also depends on how fast their emissions are added to the atmosphere, and how fast the GHGs are removed. Stabilization for these gases is described in the latest section on non-CO2 GHGs. Projections of future greenhouse gas emissions are highly uncertain. In the absence of policies to mitigate climate change, GHG emissions could rise significantly over the 21st century. Numerous assessments have considered how atmospheric GHG concentrations could be stabilized. The lower the desired stabilization level, the sooner global GHG emissions must peak and decline. GHG concentrations are unlikely to stabilize this century without major policy changes. Energy consumption by power source to create lasting climate change mitigation, the replacement of high carbon emission intensity power sources, such as conventional fossil fuels, oil, coal and natural gas, with low-carbon power sources is required. Fossil fuels supply humanity with the vast majority of our energy demands, and at a growing rate. In 2012, the IEA noted that coal accounted for half the increased energy use of the prior decade, growing faster than all renewable energy sources. Both hydroelectricity and nuclear power together provide the majority of the generated low-carbon power fraction of global total power consumption.